All right, so today's section shouldn't be too terrible. Most of you tend to kind of hang on to a lot of this from high school, which is nice. And we actually use lines in lots of different classes. So we talked about in the last class what makes a function, right? It's got to have every x has to map to exactly one y. And now what we're going to start doing is we're going to start getting into more specific types of functions. And today we're going to talk about linear functions or lines. So we saw on Friday that lines are always functions, right? They're always going to pass the vertical line test, and with the exception of one type of line, which I'll mention today. But we need to talk about the attributes of a line, and this is going to be important because later when we start getting into word problems, you're going to have to be able to construct a line. And what's really challenging sometimes for people in word problems is, like I said, we got to make sure we have the right input in the correct output variable, okay? So first of all, when we talk about lines, right, so we say a line is a set of all points, right, of the form x, y, where the change in x is proportional to the change in y. And not only is it proportional, but we typically say that there is constant slope. So if you measure the change in x against the change in y or vice versa, between any 2 points on the line, you should come up with the same value. That slope should never change over the course of the line. And that should make sense because it's straight, okay? If those slopes were changing, that's when you would get curves, right? Or we would have some twists and turns along the way in the line. So if we just sketch exactly what this definition is saying into an equation, kind of like we did with circles, all right, what we would be saying is, well, the change in y, right? So if we had y minus y naught, right? I guess I should start by saying, let's let right? So we're going to let x naught, y naught be some fixed point on the line. So it's just one specific point, right? But just x and y with no subscript are going to be the set of all points on the line. So if we're measuring the change of the y values, right, just like we did with circles, remember we said we let the x and the y go first and we let the center go second. So I'm saying, well, y could stand for any other point on the line, y naught is standing for a specific point on the line, right? So that is proportional, right, to the change in the x values. So m is the constant of proportionality, right? Or more specifically, what we're going to call it in this case is the slope. So what most of you are more familiar with seeing is if I take this equation and I just rearrange it slightly, if I divide both sides by x minus x naught, well, what you see now is the slope of the line is the change in y over the change in x. And some of you guys remember calling it rise over run, right? You step up like a ladder. So another way we can do this notationally is we can simply say delta y over delta x. So that little triangle, when we use delta, it's actually a Greek letter, I guess, technically. What that will always mean in any context, in any course that you're working with mathematically, is it means change, and it always means typically final minus initial. So if you're in physics and you see delta any variable, it's the final value you measured minus the initial value, right? So with lines, it doesn't really matter where we start or where we end up because we'll end up with the same slope anyway because it's constant. But what you do want to be careful about doing is whichever value you decide to put first here, its corresponding x value has to be here. So once you pick something to go first, you have to use the other x values. You can't mix them up in the numerator and the denominator. Also be careful with negative signs. Okay, people always kind of tend to get careless with those. All right, so if we want to write the equation of a line, right? There's usually two things that'll happen. We either have to give you the slope and a point on the line, and we can do it that way, or we can just give you any 2 points on the line, right? So if you're given 2 points on the line, well, in order to find the slope, so if we give you the slope and a point, that's actually the quickest way to get there. But if we give you 2 points, there's like one extra step. You have to calculate the slope off the 2 points before you can write the equation of the line. So if we want to find the slope of this line, right, we know that m will equal, and I'm going to call this the first point and this the second point. It doesn't matter, I could go the other way around. So the change in y would be -1, right, minus 5 over 4 minus 2. So we get -6 over 2 or -3. Should I do that algebra right? Yeah. So this line would have negative slope. Now if I want to write the equation of the line, right, I can pick either one of those 2 points. It doesn't matter which one I pick. I should end up with the same line. So if I gave you the slope and 1 point on the line, then we would still have to do the next step anyway. So what we like to do is this formula right here, right, that we wrote out earlier, you can also think of this as the point slope formula. So everything you need is right in the name, right? You need a point and you need a slope. So clearly the x and the y is the general points on the line. The y naught x naught would be the point you were given, and m would be the slope that you calculated or were given in the problem. So if we want to define the equation of the line using the point slope formula, I'm just going to pick the first point. I could have picked the second, but I'm just picking the first one. So if we say y minus -1, right, it becomes a plus, equals -3 times x minus 4. And then generally we say that we're not finished with the problem until we solve for y. So there are many, many different forms you can write a line in. Technically this is a line right here, but usually the conventional wisdom is if you don't know what to do, always put it in mx plus b form. So we do that by distributing the 3 on the right, or -3, so we'll get -3x. -3 times -4 is positive 12, and then I need to subtract 1 from both sides. And so now we have the equation of a line in the form mx plus b. So m, right, was just the slope, and b is the y-intercept. So in the same way that we said we really like to write circles in standard form because you can easily see the center and the radius, we typically like to write lines in this form because I can see the slope and I can see the intercept, and it's very easy for me to plot. So you'll always know an immediate point on the line, 0b, that's where it crosses the y-axis. And then if you know the slope, you can kind of rise over run if you're graphing and plot from there. Yeah.
Can you do point slope if you don't have m already? Like you have to get m.
You have to get m. So if we give you m and a point, you just go right into writing the line. If we give you 2 points, there's the extra step if you have to calculate the slope before you can proceed. Yep. Mm-hmm. All right. So graphically, you want to be able to figure out what's going on with lines. And there are 4 types of lines we could have. Okay, so we're going to look at 4 different types of lines. So the first, let me get a better color. The first is we can have a line that tilts up to the right. So this line, right, has a positive slope. We can see here, this is its y-intercept. So that's just 0b. And remember, whenever we talk about intercepts, we said in the first day, right, we said whenever we talk about intercepts, it's really a game of zeros. Where do you put the 0? Because if it crosses the y-axis, then the x-coordinate is 0. If it crosses the x-axis, then the y-coordinate is 0. So we always talk about lines in terms of their y-intercept. So we know that the slope is positive because if you look, right, at this line, as x gets bigger, y is also getting bigger. So what we see is as x increases, y increases. Another way of looking at that is if you're measuring the slope as the change in y over x, well, your change in y is positive because it's going up, and your change in x is positive, and so a positive over a positive is going to in fact give you a positive slope. So you should be able to visually look at a line and know whether its slope is positive, negative, or 0. You should also, if we describe a scenario to you, you should be able to infer a lot of times whether the slope of the resulting line will be positive, negative, or not, and you can do that by analyzing, well, what's happening to the x variable as the y variable increases. So for example, if I told you you were going to the doctor, or we'll say you went to the county fair, right, and they wanted to measure your sodium intake, right, and you were eating corn dogs. Well, corn dogs are full of salt. So the more corn dogs you eat, the higher levels of sodium you should have in your body. So if you were to plot that on a graph, you should see a positive slope because as x goes up, y is going to go up, right? If you're on a diet and you're exercising, right, and you're running every day, and we're measuring your weight against the number of miles you run, well, you would probably expect the more you run, right, the more calories you're burning, and you might see your weight decrease. So you would get a negative slope, typically, in that scenario. So if we ever ask you to conceptualize slope like that, we will give you a scenario that is blaringly obvious or purposely, like, obviously ambiguous. So something like, we would give you something where there was just no discernible relationship at all if we wanted it to be confusing. But usually it'll be obviously positive, obviously negative if we ask you to interpret it. All right, so the second type, right, is we could have a situation where the line's coming down like this. This would be a negative slope, and we can see as x increases, y is decreasing. And if you look at it in terms of change in y over change in x, what you're getting is a negative change in y over a positive change in x, right? And negative divided by positive is in fact negative. So there are multiple ways you can kind of prove to yourself that this line has a positive or negative slope. All right, the last two types of lines, right? We could have a horizontal line. The slope is 0. And the line is just going to be y equals some constant number. But more specifically, since we know where it crosses the y-axis is at b, right? That's what we call the y-intercept. Really, the line is just the form y equals b. Wherever it crosses the y-axis, that's its value everywhere. So if you kind of visualize this and think about it in terms of rise over run, what you've got is no rise, all run. So the numerator of the equation is 0. Delta y is 0, and then you get an x, and 0 over anything is just still going to be 0, right? So these first three types of lines are in fact functions. They all pass the vertical line test, right? So the third or fourth line, excuse me, would be a vertical line. And a vertical line, M is undefined. And the line would have the form x equals a constant. So if you think about this in terms of delta y over delta x, can anyone tell me why we say M is undefined?
There's no change.
There's no change in what? Because there's no change in a constant line in y.
This is not a function.
It's not a function, but think about the domain and range rules. What about the slope formula? The denominator would be 0. You're all rise, but no run. So what you would get is if you tried to measure the difference between 2 points, you'd get a constant on top and a 0 in the denominator. And that's rule number 1 of finding domain. No zeros in the denominator, so we just say it's undefined. That's what we say. So in this case, when you have a constant, but you're correct, it is absolutely not a function. This fails the vertical line test because the only place it exists is on the vertical line, and every single point would be infinitely many points across that line. So these three are functions. This is not a function. So the other thing that you want to make sure you can visually see is you can think of the slope, right? These two cases are special. These are just vertical and horizontal. But if we look at these two lines, you can think of that slope as sort of like a ramp or a hill or maybe a rooftop or something. So as the slope gets steeper, right, or the line gets steeper, the value of m should go up. So let's look at an example. So let's say I have the line y equals 2x. So since there's no b, right, it's just mx plus 0, right? B is 0, so we know this guy crosses the origin. Okay? So this line has a slope of 2. And I can just grab that right out of the line. But if I plot this line on the same graph, and this is y equals 1/2 x. So if I didn't give you the equations and I just plotted the two lines on top of each other on the graph, you should be able to see that the blue line has a bigger slope than the red line. And so as the slope gets smaller, the line gets, and think about it like this, right? The slope, when the slope is 0, you're horizontal. So as the slope gets smaller, you're getting closer and closer and closer to being level, right? As the slope gets bigger, you're getting closer and closer and closer to being vertical. So whenever you're comparing two lines, you should be able to visualize or put in order which lines have the largest slope and which ones have the smaller slope. Now, I can't remember if Alex does this to you or not, because I want to say I might have seen one of these last semester in Milledge Hall. But if you're given a graph and with a bunch of different lines overlaid, and one of the things they might do sometimes is exercise, they'll say, rank the lines from decreasing to increasing slope, okay? So if you see positive and negative lines, right, first of all, what you want to do is the magnitude of slope or the size of the number is going to be based on the steepness of the line, no matter whether it's positive or negative, right? However, you then have to distinguish between positive slopes and negative slopes. So typically what you would do in an exercise like that is you would imagine that you plot all those numbers on a number line and you would read them from left to right. So if you had a line with slope -5, that is smaller than a line with slope +3. Even though the -5 line would look steeper, it's going in the negative direction. So if you're plotting things that can take on positive and negative values at the same time, you're supposed to plot them on a number line, and the biggest negative number goes first, and you go up to the largest positive number. Does that make sense? And then 0 would be like right in the center. Okay. Because sometimes if they said, and you guys don't really get into that in here too much, if they said magnitude, like if you're in a physics class, magnitude would just mean plot it by the number itself. Like I want to see the steepest versus the most shallow, but usually we go negative, then 0, then positive. All right, so let's do an example. We have a line, oops, it doesn't grow, excuse me, it goes through points 1, 2, and 2, 5. And we want to know what the line is. All right, and then in a second, I'm going to give you one with a fractional slope and show you that there's a little algebra hack you can do when you're doing these problems. It's pretty cool. All right. So if you want to do this line, right, the first thing we have to realize is we were given 2 points, and so we have to calculate the slope first before we can proceed. So the slope, right, is going to be the change in y over the change in x. So we'll say 2 minus 5 over 1 minus 2. So that gives us -3 in the numerator and +1 in the denominator. So that just simplifies to -3. So it's easy and nice when the slopes are whole numbers. If we want to write the equation of the line, right? So we're going to do this using both points, just so you can see you end up with the same answer. So if I use the first point, I would say, well, y minus 2 equals -3 times x minus 1. When we distribute out the right side and solve for y, did I do this right? 2 minus 5, 1 minus 2. Yeah, okay. Very sleepy. All right. So that's our first line. Well, if we do this calculation again using the second point, right, we'd say, well, y minus 5 equals -3 times x minus 2. So y minus 5 is -3x plus 6. And y would equal -3x, I'm getting plus 11. I should not be getting that. I should be getting the same answer. All right, did I make an algebra boo-boo somewhere? Y minus 2, did I do this right? -3 plus 3. 2 plus 3 is 5.
You did 1 minus 2
Yeah,
is 1.
Yeah, you put it as +1, it should be negative.
Oh, thank you, thank you, thank you. Oh, I knew it. See, there's always something. All right, so this should be +3, +3, that makes that a minus, so then that becomes positive, and so then when we add 2 to both sides, we should get -1. Oh, thank you guys. All right, so then that's positive, so then we get -6. Oh, yeah, there we go. That's positive, so then when you add 5, you get -1. Okay. Yeah, I was like, we should be getting the same exact answer for both points. This is why you get a good night's sleep before you take a test, too. This is rough stuff. All right, so the point here was that you can use either point and you will get to the same answer. So if you get to choose between points, right, in this case, it was kind of like 6 of one, half a dozen the other. But if one of your points has a 0 in it, always go for that one when you're plugging in the line, right? It just makes stuff really easy. So if you get some 1s, those are great, right? So anytime you have 0s and 1s, those are good guys to pick. So what I want to show you guys is an algebra hack for when you're doing these and involving fractions, okay? Because algebraically, if you look what we did here, when you set up the point slope formula, you have to distribute the right side, and then you're going to always have to add a number most of the time from here over to here. And adding a whole number to fractions, it just gets messy and gross. So there's a really cool way you can do this to eliminate the fractions. So let's imagine we have a line with a slope of 2/5. And 0.12 lies on that line. So if I want to write, come on, there we go. If I want to write the equation of this line, I'm going to use the point slope formula. So I say y minus 2, right, equals 2/5 times x minus 1. So the next step of algebra would be to distribute the 2/5. And then you would have to add 2 to 2/5, right? When you bring the 2 over from the other side to solve it for y. And that's gross. So there's a trick you can do, and this will work for any time you have, and actually this works for any problem with fractions, okay? So what you can do is you can multiply the entire equation by the common denominator. And for a line, the common denominator is usually just going to be the denominator of the slope because everything else are whole numbers unless you have fractions as your points. So if I multiply this entire problem by 5, right, and that's a legal algebra move because as long as whatever I do to the left side of the equation, I also do to the right side of the equation, it's allowed. So let's start on the left side. So I'm going to distribute this 5 all the way across. So on the left side, I'm going to get 5y minus 10. And on the right side, the 5 just cancels the 5 in that denominator. And since these two terms are being multiplied, once I've canceled the 5, I'm done distributing on the right side of the equation. So now all I'm left with is the 2. So I'll get 2x minus 2. And if you look now, I have an equation with no fractions in it. So then I just need to finish this problem by solving for y. So I'm going to add 10 to both sides. And positive 10 plus negative 2 is positive 8, okay? And then, now when I'm down here, right, I have to divide everything by 5. So remember when you're doing your algebra to remember context of what you're doing. So the natural student inclination, a lot of students, they would just put a big fraction bar and just put the whole thing over 5, okay? That is not mathematically incorrect. However, this is a line and I want it in mx plus b form. I want to be able to see the slope distinct from the intercept. So what you're really doing is you're really multiplying the whole equation by 1/5, right? So you want to have 2/5 x plus 8 over 5. And if you've done this correctly, the slope should come back in the final line exactly in the form it was you started with in the equation. So that's one of the ways you know you've maybe done your algebra right. The 2/5 should come right back at the end. And we now know what 2/5 plus 2 is. It's 8/5. It just kind of organically comes back at the end of the problem. So these are, that's something good to practice with when you're doing these. It makes things go a lot quicker. All right. I have another problem I want to do with you guys. All right. So there's one other thing I want to talk about with lines. Okay. All right, parallel versus perpendicular. So if you're given two lines and you want to find out if those lines are parallel or not, right? And what we mean by parallel lines, they will never, ever, ever cross. They have the exact same slope, right? And they're just sitting, it's almost like a gap between it. And they'll never, ever, ever cross. So for parallel lines, right, it's two lines, right, that look like this. And that gap between them could be really big, could be really small, but we know that no matter where you go from positive to negative infinity, they're never going to cross. So for parallel lines, they have to have the exact same slope. And so typically the way we write that notationally is we say, well, the slope of line 1 has to equal the slope of line 2. So if we give you a bunch of lines and we ask you to compare whether they're parallel or perpendicular, you have to put them each in mx plus b form so you can extract the slopes and compare them. If lines are perpendicular, well, then they cross, right, at 90 degrees. So when they intersect, right, they intersect at a 90-degree angle. And we say that the slopes are negative reciprocals of each other. So if you want to come up with the slope of a perpendicular line, you flip the original slope and then you multiply by -1. So one thing you want to be careful with, right? If M1, right, equals 2/5, right? And we have a second line whose slope is 5/2. Then our two lines are definitely not parallel, right? But they're also not perpendicular. And we use that little upside down T to be perpendicular. So why aren't they perpendicular either?
It's not negative.
Not negative, right? So it's got to be flip it and then multiply by -1. So this is a really common thing to do, is give you a bunch of slopes and you'll see the same numbers repeated and everybody will be like, oh yeah, it's upside down, it's good to go. Nope, it's got to be the negative reciprocal. So if we go back and say if M, right, if M1 equals 3/2, right, then M2 equaling 3/2 makes it parallel, right? And what's the perpendicular slope going to look like for this? -2/3, yep. Right, it's perpendicular. All right, so there's one more really, I'm trying to decide, I want to do a word problem here. I'm trying to pick which one. Okay, yeah, I wanted this one. All right, so let's do an application problem. Creating a line from kind of a word scenario. All right, so imagine that we have two factories, okay? And factory 1 produces 2 items per hour. And every day it starts out with 4 already made for the day. So we can kind of imagine, I guess, that when the factory shuts down the night before, it always makes sure there's 4 of these items ready to go in the morning. But when you turn the machines on, it's going to crank out 2 per hour. So if I want to write a line that expresses how many items are on the factory floor at any given time during the day, I actually already have my slope and my point, okay? So the initial value that we were given is we're told at time 0, when we start the clock every day, right? We're dealing with time, you always imagine that at time 0 is the beginning. So at time 0, right, there are 4 items on the factory floor. So there's a point on the line. The slope, if you look at the units here, items per hour. Well, the per is usually, if you think about it, when you put it in an equation, it becomes a fraction bar. So items is your change in y, that's what's going to come out of the equation, and time is what's going into the equation. So there's 2 items for every 1 hour, so it's 2 over 1 is the slope, so it's just 2. Does that make sense? Right? You can use the units. So if I write the equation of this line, we'll get y minus 4, right, equals 1 times x minus 0, and this simplifies into y equals x plus 4. And probably to be more accurate, I probably should have used a t, but we'll just stay with x's and y's for now.
Where did you get the 1? Isn't that 2?
Oh, 2. Thank you, guys. Oh. See, that's how I know you're awake. Okay, so it's just 2x plus 4, yeah. Thank you. So the second factory right, it produces 1/3 items per hour, which is a very cumbersome way of describing it. So typically in the real world, we wouldn't say, oh, I make 1/3 of a thing an hour, right? This is just to keep our unit simple. Really what happens is we make 1 item every 3 hours, right? And that, if you read this, that's what it says, 1 item every 3 hours. So that would translate into 1/3 of an hour, okay? So we produce 1/3 items per hour, right? But since this is slower, we have 8 ready at opening each day. So the initial amount, right, is going to be our initial value at 0.8, and our slope is 1/3. So y minus 8, right, equals 1/3 times x minus 0, which gives us a line of 1/3 x plus 8. And I want to know, what time of day do the factories have the same amount of items on their factory floor? So how would you figure that out?
Set them equal to each other.
Set them equal to each other. So there's two actually ways we could do this. We could plot them and graph the two lines, and where the lines intersect, that would be where they have the same, share the same point and have the same value, and you could look at that way. Or algebraically, the way you achieve the same thing is you set the two y values equal to each other and you figure out what x value gives you that time. So if we set these guys equal to each other, we had 2x plus 4 equal to 1/3 x plus 8. And so now we want to get like things together. Now, once again, I don't want to deal with any fractions. So I can actually use my algebra hack, and I can say, well, I'm just going to multiply the whole equation by a common denominator, which is 3. And I'll say, well, 6x plus 12 equals x plus 24. So now I'm only dealing with whole numbers. So I'm going to subtract an x from both sides and get 5x on the left. I'll subtract 12 from both sides and get 12 on the right. So x equals 12 over 5. And so if we're assuming that the two factories open at the same time every day, then whatever this works out to be, it's going to be 2 and some change, right? About 2, maybe just under 2.5 hours. So if they open at 9, it's going to be around 11, between 11 and 12 every day is when they'll have the exact number of items.
So what would the x-intercept be like? Would it be like 2 point whatever?
Well, this is not the x-intercept. This is the point, this is the
When they
point.
intersect.
Oh, if you want it, yeah, this is the point where the two lines intersect each other, right?
Oh, so it'd be, okay.
And if you wanted to know how many items were on the floor, that could be the follow-up question. Well, then plugging that x value into either one of the original two lines would tell you exactly how many items, but you should get the same answer because it's the same amount for each one. Okay? All right, so we'll call it there.